Hello, everyone. Today, my teammates and I are here to give a presentation on our project analyzing the cost of living in the United States. So, this is the outline of our presentation and all the slides we have included in our presentation. So, coming to the project overview, the project aims to predict the total cost of living across US regions using machine learning models, focusing on factors like housing, food, transportation, childcare, taxes, and healthcare. The goal is to develop a user-friendly application that provides real-time cost predictions to support decision making for individuals, businesses, and policymakers. By leveraging robust models like gradient boosting and emphasizing dynamic interactive visualizations, and this project bridges the gap between complex data analysis and practical usability. This tool offers actionable insights to address the rising costs of living, enabling users to make informed financial decisions tailored to regional conditions. And to give an introduction on our project, I would start off with the fact that the rising costs of housing, food, and healthcare have significantly had an impact across millions in the US, creating a pressing need for accurate and user friendly tools to predict and manage living expenses. Existing solutions lack precision and accessibility for dynamic, real time cost predictions, and this project helps in addressing and developing a robust machine learning based system that predicts the regional cost of living. And the tool empowers all the individuals and policymakers to make them informed about their financial decisions by analyzing critical expense factors and incorporating advanced models. And the project also ensures high accuracy, adaptability to complex data, and an interactive platform for seamless user experience. So, in the related work, the previous research on cost of living predictions relied on basic regression models, often lacking real time capabilities and user focused applications. The key insights from studies from Friedman highlight the effectiveness of gradient boosting in capturing complex data relationships, while Domingos discusses the challenges posed by noisy data and regional cost variations. These studies underline the limitations of past approaches, including inadequate adaptability to real world complexities. This project contributes by utilizing all of the machine learning models and offering a very interactive and user friendly application which focuses on precision and accessibility and ensures actionable insights for the diverse users and decision makers. In the proposed work, we initially started off with data collection and pre-normalization, where the data set of the cost of living was taken and various factors like housing, food, and childcare was considered. We handled the missing values, normalized the features, and used one-hot encoding for the categorical data. And then we proceeded with feature selection and identified the most critical predictors using the techniques like correlation analysis and feature importance. And the model selection and training included comparison of models between linear regression, ridge regression, random forest, and gradient boosting. And we optimized the best performing models under scenarios like noisy datasets and nonlinear datasets. This system was built on the backend using Python, which was very efficient for data processing and prediction. And the front end was based on Streamlit, which helped us in developing a very good real time and user input and cost predictions. For evaluation, we tested the models under conditions like clean, noisy, and nonlinear data, and we validated our performance using metrics like mean square error and R square values. The application for this tool was developed in a very user friendly manner and designed to provide real time costs for living predictions. The features input fields for essential expense categories such as housing, food, childcare, and transportation. And the tool instantly calculates the total cost of living, offering detailed breakdowns and dynamic visualizations like bar charts and heat maps. Streamlit was used for the interactive user experience, which allows the users to adjust the parameters and explore how changes in expenses affect overall costs. And the application helped us do a complex data analysis and practical usability and ensure that we bridge this gap, empowering the individuals, businesses, and policymakers to make sure their decisions are taken effectively and efficiently. This is how the application's user interface looks like. In the tools and technologies used, the project employs various tools and technologies to ensure efficient development and accurate predictions. The backend was built using Python and utilizes libraries like scikit-learning for machine learning models, pandas and numpy for data pre-processing, and matplotlib for the visualizations. Data pre-processing techniques included standard scalar for numerical scaling and one-hot encoding for categorical features. The front end consisted of Streamlit and it provided a really good interface which was very dynamic and interactive for entering real time input for the cost of living visualizations. And the development was conducted in Jupyter Notebook for model training and testing. And we had the use of GitHub for version control and collaboration. So these technologies collectively enable us to develop a robust, user-friendly, and data-driven cost prediction application. And from here, my teammate Tarun will take over.
Hello everyone. Now I'm going to explain about the methodology. The methodology leverages gradient boosting as the primary model due to its ability to capture nonlinear relationships, handling noisy data and prioritize impactful features. Data pre-processing method ensures consistency by imputing missing values, normalizing numerical data, and encoding categorical variables. Identifying key predictors like food and housing costs. The gradient model is trained and validated under like driver's conditions, clean, noisy, and nonlinear datasets. It demonstrates the adaptability and accuracy. This robust approach ensures high R score values and low MSE values. And it is very useful for predicting regional cost of living with real world complexities in mind. And when it comes to the feature importance, the feature important analysis highlights the most impactful predictors in the cost of living model. Food cost contributes 40% to the predictors, making it the most significant factor, while the childcare cost accounts for 20%, while the house cost adds like another 15%. By focusing on these critical predictors, the model achieves improved accuracy and reduced overfitting. This analysis not only informs model refinement but also guides policymakers. Next slide. And when it comes to the distributed costs, the distributed cost slide visually represents how different expenses categories contribute to the overall cost of living across the US regions. The graph illustrates the key patterns such as childcare costs, housing costs, which collectively dominate the model. The additional categories like transportation, taxes, healthcare, and showing various contributions. And these visualization provide a clear breakdown of cost distribution. It helps the users like to identify high impact areas, and the graphs serve as a powerful tool for understanding expense dynamics. Next slide. And the first experiment established a baseline by testing models on clean pre-processed data. So the first experiment is the model performance on standard data. This technique, it imputes the missing values and it normalizes the numerical features, and then these features are applied to create an ideal data set. The linear regression, ridge regression, gradient boosting, and other models like random forest models for train and tested with gradient boosting technique in order to get high accuracy. And when it comes to the second model, next slide, please. Because the second experiment focused more on robustness to noisy data. A common challenge in the real world data sets is that the random noise was added to the data to mimic the imperfections, and the models were reevaluated. While most models experience performance degradation, and the gradient boosting maintained high accuracy, demonstrating its ability to handle data imperfections effectively. And next slide, please. And when it comes to the third experiment is all about handling nonlinear relationships. Uh, it's like introducing the nonlinear relationship by applying polynomial transformations to key features. So these models, challenging models to adapt complex interactions, and the gradient boosting technique once again outperformed all these challenges. So overall, the gradient boosting technique has emerged to be the most reliable and adaptable model, excelling under clean, noisy, and non-linear data conditions. Next slide. The results and analysis slides highlight the performance of various machine learning models and the insights derived from the feature importance in predicting the cost of living. Next slide. The models were evaluated under clean, noisy, and other data. Linear regression and gradient boosting achieved perfect R score values of 1. But linear regression was like, as you can all see, that it was prone to overfitting. And the ridge regression, it has an R square value of 0.95, performed well for linear relationships. So this demonstrates the robustness and ability to capture intricate dependencies effectively. Next slide, please. So when it comes to the feature importance, the analysis identified critical predictors with food costs contributing 40% and childcare it contributes 20%. So the it is the key factors. So the correlation analysis reveals strong relationships between housing, food costs, and total expenses. So it reinforces their significance. This feature prioritization not only improves the model accuracy but also interpretability. And as you also can see that this is the output graph. The gradient boosting technique has emerged to be the most reliable model for cost of living prediction. So these results underscore its effectiveness in handling diverse data complexities, and it provides actionable insights, and it is also very good model in decision making and in understanding the regional cost drivers. Next slide. uh, yeah, now the demo will be explained by my teammate Himadipika.
So, before getting into the demo, I'll explain what exactly our application contains. It has two main pages: the introduction page, which provides a brief overview of the tool's purpose, And it also guides users to the prediction page, which is like the second follow-up page, which allows users to input expense details, including food, childcare, taxes, healthcare, and other details. These inputs are then validated within specified ranges and processed into a numerical array. The scalar pre-processes these inputs, and the scale data is passed to the pre-trained model, which predicts the total cost of living. And then the total result is dynamically displayed on the page. So this is the introduction page of our application. And when we go to the prediction page and enter the values, we get the estimated total cost of living for that region. We can also try out other values by clicking on try other values. So this is the form page that I just showed. So the code we've used, it implements an interactive cost of living prediction, and we've used Streamlit tool for that. It combines a custom gradient boosting regressor class with a pre-trained machine learning model for actual predictions. The gradient boosting logic, it involves creating multiple decision trees that iteratively improves the prediction by focusing on the residuals from previous steps by refining the accuracy over several iterations. However, this tool, it uses a predefined model um, and a scalar for predicting and ensuring accurate and consistent results. So this is the heat map that we visualized for comparing the different variables that is there in the data set. So the correlation matrix that we just saw, it visually represents the relationships between various expense categories and total cost of living. It highlights strong positive correlations such as between housing and other necessities and total cost with other necessities, indicating that these factors often rise together. So moderate correlations like food and healthcare and childcare with total, these show significant but slightly less impact, as you can see in the diagram, and weaker correlations such as median income and specific costs suggest limited direct influence except for housing. So this analysis, it helps to identify key cost drivers and interdependencies, improving model accuracy and guiding financial decision making strategies. The key challenges that we faced during this project was that we had to handle a lot of noisy data and incomplete data, which required robust pre-processing techniques like imputation and scaling. And then regional disparities in cost factors posed additional difficulties as the varying income conditions impacted the model generalizability. To address these challenges, um, me and my teammates, we utilized gradient boosting for its resilience to noisy data and ability to capture complex patterns. And future enhancements are proposed, such as expanding the data set to include more regions and factors like entertainment or environmental conditions, ensuring a broader applicability and great accuracy in cost of living prediction across diverse scenarios. To summarize, we have developed a robust machine learning based tool which was developed to accurately predict the cost of living across US regions, and gradient boost was used for excelling in handling diverse data complexities such as noise and non-linear relationships. The project also featured a user-friendly dashboard, bridging technical analysis and practical usability. And our tool also provides actionable insights for financial planning, policy making, and business strategies, which empowers users to make informed decisions. So, for future work, we aim to improve the tool's scope and accuracy. Data integration will include like live streams, like inflation rates and market trends, as well as socioeconomic metrics such as quality of life. We would also like to provide technical advancements, including deep learning models like RNN will be explored for temporal data analysis. And we also aim to enhance user experience by using geospatial cost visualizations and enabling regional comparisons and new features like affordability. So these are all the references that we have used for our project. Yes, thank you so much.